today's lecture on numerical analysis, and here we discuss how to find the solution of initial value problem which is given by y double dash minus y, this is equal to x, with the initial condition y of 0, this is equal to 0, and y dash 0, this is equal to 1, using a very important method of numerical analysis which is finite difference method, right? And we have to find the value of y at the point x equal to 0.01, 0.02 and so on. Okay, and this is the second lecture on finite difference method. We already discussed the detailed algorithm and detailed deduction of algorithm of finite difference method in the first lecture. Okay, so we write the result of the first lecture here. Okay, here we get y dash x, this is given by y of x plus h minus y of x by h plus order of h. This is forward difference, and this is for backward difference, and this is for central difference we say, or it is given by the sum of these two, that is the average of 1 and 2, we get this result. Okay, and here we, in this method, we replace y dash x by this or this or this. Okay, and also using the same method or the Taylor series expansion, we get the approximation of y double dash x, this is equal to y of x minus h minus 2 into y of x plus y of x plus h by h square plus order of h square. Okay, we write this 4 result from the previous class. Okay, now here we write this result first by using the suffix I. Okay, so we write here, this is yi double dash x, or we only write yi double dash. This is given by, this can be written as yi minus 1 minus 2 into yi plus yi plus 1. Okay, that is we take x equal to I and h equal to minus 1 or plus 1. Okay, by here we write h square. This is the step length. This is the approximation of yi double dash is this in finite difference method. Also here we use the approximation of first derivative. We use the first result, that is the forward difference result. We write here yi dash, this is given by yi plus 1 minus yi by h. Right, now here from the given result, if we put here I equal to 0, right, I equal to 0, then we get y 0 dash, this is given by y 0 plus 1 minus y 0 by h. H means here h is given by, it is clear that h is given by 0.02 minus 0.01, so h is 0.01. Okay, so we write here 0.01, and this is given by y dash 0, this is y1, and this is given by y of 0 by 0.01, right, and y dash 0, this means y dash 0, this means 1, it is given, so we get the result of y1 minus, we put y of 0 means it is also given, this is 0, this is given by y dash 0, we put here, this is 1 into 0.01, right, so we get y1, this is equal to 0.01, this means y of 0.01, this is equal to 0.01, this is y1. Okay, so we get the value of y at the point x equal to 0.01 very easily from this approximation or from this result. Okay. Now we put the value of yi double dash in our given equation or given problem. So given problem can be written by writing as yi double dash minus yi, this is equal to xi, and this gives the result as we put yi double dash, this means the result yi plus 1, we write first this minus 2 into yi minus plus yi minus 1 by h square minus yi, this is equal to xi. Okay. Now here we put I, this is equal to 1. Okay. So we get y1 plus 1, this is 2, minus 2 into y1 plus y0 by h means 0.01 whole square minus y1, this is equal to x1. And putting all the value we already given here, already get here one by one. We first put the value of x1, x1 means 0.01, already put h, and we already get y1. So by putting all the value we get y2 minus 2 into 0.01 plus y0, this means 0, it is given by this is 0.01 whole square minus this is y1, this means 0.01, this is given by x1, x1 means 0.01, okay, sorry, 0.01, and get the result as this is equal to, and here we write plus. Okay, so this gives 0.02. Now y2 minus this is given by 0.02, and this is equal to 0.02 into 0.01 whole square, and this is equal to 0.02 into 0.0001, right? And this result gives, this is 0.00002, okay, because here 4 and here 2, 6 decimal places, we write here another 0 and then 2. This is the 6 decimal places. Now the value of y2, this is given by 0.02 plus 0.000002, and this gives the result 0.020002. Okay, this is 1, 2, 3, 4, 5, 6 decimal places. So we get the another result. This is y of 0.02. This is given by 0.020002. Okay, this is the second result. That is, we get the value of y at the point 0.02. Similarly, I think the third result is y of 0.03. This is equal to 0.030003. In similar manner, we get this result by putting the value of I equal to 2 here. Okay, and similarly using the previous value, that is using this value, we get the value of y of 0.03, and using this value we get the value of y of 0.04, and so on. Very easily we find all the value of y at the point 0.03, 0.04, 0.05 and 0.06. Okay, and this is the today's class. Very important problem, but easy problem of finite difference method. And generally finite difference method is used in boundary value problem, and exceptionally it is also given that to solve the initial value problem using finite difference method, and this is an example of this type. Okay, thank you for watching.